So, are there any questions over the homework before we start today's lesson? So, I'm going to start with this one here. I know yesterday I said that we were done with the sum and difference of perfect cubes. We're going to move on to grouping. I wanted to look at this one here. It's not really any different than the previous one. The only difference is that we do only have one variable, and it's in the second spot. We did have one yesterday where we did have a variable in the second. We also had one in the first. So I want to look at this one here so we see one variable in the second position and kind of how it works. And kind of, there's only one thing different, but it's just how we rewrite the final answer. Otherwise, it's the exact same. Now, the first thing we can look for in this here is a greatest common factor, which there isn't one. So we can go on and do the cubed root of 125 and x to the third. And this is really, one, to show that these are perfect cubes, and two, to find out what our two terms are. Well, the cubed root of x to the third is x. Now, the cubed root of 125, we can type it into the calculator, and we get 5. Yeah, I did it first hour and haven't cleared it. No. Yeah, no, I typed it in there first hour. So we get 5. Three spots and 5 spots. Now the next thing we can do is our signs. So since we have a difference, our first sign is the same, so it would be minus. Then we have opposite, which would be plus, and always end on a positive note. So we have minus, plus, plus. Now our first term this time is 5, unlike the previous ones where it's been a variable of some kind or a number and a variable. This time we just have a constant term. So here we'd have 5. In the first spot in the bigger one, we'll have 5 squared. Here we'll have 5 to the first, and then we would have 5 to the 0, or we wouldn't include it. Because 5 to the 0 would be 1, and then we would multiply it with our second term, which just gives us the second term. Now our second term is x, so we'll put it here. We don't put 1 with 5 squared because it would just simplify to 1, and 5 squared times 1 is just going to be 5 squared. Then we'll have x to the first in the middle, and the last one's going to be x squared. Now at this point we can simplify a little bit, so we'd have 5 minus x times, well, 5 squared is 25, plus 5 times x is plus x squared. And that there would be simplified. So this here is the correct answer, the correct way to factor this. Now, we can rewrite this quadratic in standard form. Just putting x squared plus 5x plus 25, just reordering it. And there's nothing mathematically wrong with doing it this way. That's fine. I like it kind of having it in standard form. But something, I don't like switching the 5 and negative x, because we can do that, but it'd be negative x plus 5. I don't know why, I just don't like having the negative x plus 5. I don't know if it's just me, it looks nicer as 5 minus x instead of negative x plus 5. So all 3 of these are right. I just like the top 2 better. But that's it. Questions on this here? Now the last type of factoring that we're going to look at is factoring by grouping. Now the way that we group these doesn't really matter. But normally, I'll just take the first 2 and group those, and the last 2 and group those. And whenever we do factoring by grouping, if it's going to work, we do need an even number of terms. So here we have 4, 6 works, 8 works, as long as we've kind of got this even amount. With 6, we would do 3 and 3. We have 2 groups we can work with. 8, we can do 4 and 4, but we need them to be the same. So when we look at this here, factoring by grouping, or as I sometimes call it, greatest common factor twice, is first thing we look for is we're looking for a greatest common factor in the first 2 and the last 2. Yep, so we can factor out p squared. So p squared, so the 2 stays the same, but if I take 2 away from 3, we're left with 1. P to the third divided by p squared is just p plus, bless you, 5. And if we factor out p squared from p squared, it simplifies out completely, leaving us with just 5. All right, and then with 6p and 15, the greatest common factor is 3. And if we factor 3 out of 6p, or 6p divided by 3, we're left with 2p plus 5. 15 divided by 3 is 5. So that's the first step of our first time that we use a greatest common factor. Now, once we do that, both of these terms have a common factor of 2p plus 5. And even though it's more than one term, we can still factor it out of both of these here. Because if we divide it out of the first term, the only thing that's left is p squared. And when we divide it out of the second term, the only thing that's left is our plus 3. Now 2p plus 5 is completely factored. P squared plus 3, we would need to look at it and see if we could factor it. And since it has 2 terms and p is squared, the only way we could possibly factor it is if it's a difference of perfect squares. Well, it's a sum, it's not a difference, so we can't do anything with it. So that's as far as we can take it. And the reason I say that is if we think back to, remember back to yesterday when we dealt with the x to the 4th minus 81, because we factored it with difference of perfect squares, but then the other one could factor again. So it's just making sure it's completely factored. There's nothing else we can do with it. Questions on this here? Now with any of these here, we'll look at this one next. I always take on or look at this, and we can do the first 2 and last 2. And looking at these 2, I picked the one that I think would be easiest to find the greatest common factor with. So which one can we see better, the first 2 or the last 2? Last 2, what's the greatest common factor between 9 and 12? 3. We'll see that here in a minute. So we can factor the 3 out of these 2. So if I factor the 3 out of the 9 in, we have 3 in. If I factor the 3 out of negative 12, we have negative 4. And the 3 is positive, so we'll put a plus. Now for us to do the other set, or our next set of greatest common factors for our next part, we need the first one to have what? 3 in minus 4 in the parentheses, yes? Yeah. That's why I normally do whichever one I see easiest or see first, because it gives me a blueprint. It gives me an idea of what the other one should be. So I know how they should work together. Now we can factor the 3 in minus 4 out of both, which will leave us with n squared plus 3. Questions on this here? Now again, we can do this in any order that we want. So if I wanted to, we could say 3n cubed plus 9n squared minus 4n squared minus 12. because we could look at it, not square, 9 doesn't need it square. So we could look at it like this here. Now the first two do have a greatest common factor of 3n. So that would leave us with n squared plus 3. Over here, we'll need n squared plus 3. Well, so we need to factor out a -4 from both. -4 from -4n squared gives us n squared. -4 from -12 will give us plus 3. And if we factor out the n squared plus 3, we're left with 3n minus. Same place. It's just different ways that we can get to it. So just depending on how you pick it, it's going to depend on how you get there. Questions on this here? I normally pick the first two and last two because I don't have to rewrite everything to get there. This is the last one we're going to look at. Now we can start off with saying, is there a greatest common factor between these 3 or 4 terms? So we can start off by grouping the first two, last two. Now we could go in the yellow calculators and try every possible number. We can see what makes greatest common factor with these here. There's different ways to do it. Now, this out. In the graphing calculator, if you hit math and go over one to number, if you see the 9th one down, GCD, it's greatest common denominator, also works as greatest common factor. We can go and select this part here and type the two numbers in. So 224, comma, 56. And we put a comma between them to signify for the calculator there are two separate numbers. And if we hit enter, it'll tell us what the greatest common factor is, which in this case is 56. So if I wanted to, say, do 21, it would tell us that the greatest common factor is 7. So it will tell us what it is. Now that's good to know for us to know because it means these two numbers here are both divisible by 56. 56, and we would also have a, because they do both have a in common. Now 224 divided by 56 is 4. So that tells us that we do have 4. The a factors out completely, but we're left with z plus, well, 56 divided by 56 is 1. The a factors out completely, so all we're left with is c. Now, if the c had factored out also, we would have just written plus 1. Because if something factors out completely, everything is gone. All we have left is 1. Because when we factor it out, we're really dividing that term. And there's no way to divide two numbers and get 0. It just doesn't work. Let me rephrase that. The only way we can divide two numbers and get 0 is if the numerator is 0. If we're dividing two non-zero numbers, we can't get 0 from it. Now, we have this here. So, it is telling us that the other set of parentheses should be 4z plus c. For us to be able to factor it out again, it needs to be this. Well, looking at both of these here, both of these numbers are negative, yes? So to make them positive, we have to factor out a negative. Well, let's see what, if I divide 84 by 4, let's see what we get. 21. Okay, well, that means both of these here are divisible by 21 and 7. But 21, because if I factor 21 out of 84, I get 4, yes? Which is what we wanted. 21 divided by 21 is And we also need what? So the greatest common factor between those is negative 21y. Is everybody able to follow that rabbit trail of a thought process? Now, we do have something in common with both of these here, 4z plus c. And when we factor that out, we'll have 56a minus 21y. Now, if the problem was asking us to factor it, we have done just that. We have factored it. If it asks us to factor it completely, this is not necessarily the correct answer. As this is factored, we can say for sure that this is in factored form. But if we look at this one here, 56 and 21, I can pull the calculator up. (56) and 21 do have a greatest common factor of. So the answer that we do have here is factored. We did factor it, but it is not completely factored. Because if you remember back to the homework we had from Tuesday, one of the problems was 5 times the parentheses. That is still factored because we factored out a greatest common factor. So since it has a greatest common factor, it isn't considered completely factored. It is considered factored, but not completely. So on some of the ones on the ACT, it says factor completely. They probably would give this as one of the answer choices. It's the wrong answer choice because it's not completely factored. We have to factor that 7 out. So this here, what we would do is factor the 7 out. 56 divided by 7 is 8a. So I would write it, because this would be factored completely. Minus 21 divided by 7 is 3y. Now we still have the 4z plus c. So this here is factored completely. The other one's just factored. So whenever the problem asks for something to be factored completely, we have to take it all the way. But otherwise, that's it. Yes. Science. Same as reading.